Lesson 3, Machine Learning Workflow.
At the end of this lesson, you will be able to describe the 7 steps of a machine learning workflow.
Machine Learning Workflow.
In machine learning, it is essential for all technical and non-technical stakeholders to understand its workflow, to be familiar with the job of the data scientist, the processes a data scientist follows to provide feedback to decision makers, and the machine learning process in the business environment. The goals of data science and machine learning are to derive answers to business challenges, derive meaningful conclusions for complicated issues, and identify actionable items with a wide set of variables. The entire machine learning process can be divided into 7 steps. The first one, get more data. 2, ask a sharp question. 3, tabulate the data. 4, check for quality. 5, transform features. 6, answer the question. And 7, use the answer. Step 1. The first step in the machine learning workflow is data collection. Data can be collected in different formats. The data collected is used to investigate a business challenge. The quality of the predictive model depends upon the quality and quantity of the data gathered. Examples of different data formats are names, numbers, names that look like numbers, and numbers that look like names and can be converted to numbers. Once the data has been collected in the required quantity, we can move to the next step of machine learning workflow, which is ask a sharp question. Step 2. To be able to use the machine learning process and define answers to complex business problems, it is important to avoid vague questions and ask sharp questions instead. A vague question is generally too broad to answer. The answer to a vague question does not always provide us with the information that we're looking for. And unlike vague questions, a sharp question is direct and focuses on a single point or topic so that we can get a clear answer. It also focuses on the exact need and requirement. Let's look at some examples of sharp and vague questions. Examples of vague questions are: what should I do? How should I live my life? Which career path should I take? What can data tell me about my business? On the other hand, sharp questions will be more like: which route will get me to work fastest? When are you planning to join the company? How many times will users use the new product feature? Where did you go to college? From these examples, we can see that vague questions can be answered in multiple different ways and might still not give us the information that we're looking for. Using sharp questions instead will help us get relevant information. As we already know, the data scientist takes the raw data and feeds it into a database in a systemic format for further investigation. Now, let us take an example for better explanation. Suppose you're running a company and you are the CEO of this company. You want to study different tables of data from the database that we have and use it to analyze the company's monthly performance in terms of sales and ultimately the company's market share. Here, your main goal is to be able to analyze the company's historical data and predict stock price in a future date. Step 3. The next step in the machine learning workflow is organizing the data in the table. The data analyst takes up the raw data and feeds it into the database in a tabular format so that the raw data can be arranged in a systematic manner. The systematic arrangement of data fosters a more detailed and better investigation to find the answer to the question. The tabular data is stored in the form of columns and rows, where each table column represents the data of a single type, and the rows provide related information about the column type. Afterwards, the data analyst focuses on the aggregate of table data by counting the total observations in a table and or combining data from multiple tables to answer a particular question. This process is also known as data analysis.
Data analysis is a process of evaluating each data component so that useful information or findings can be identified from the historical data. Data analysis mainly focuses on the aggregate table data to find answers to business problems. It is also performed by data analysts to build machine learning algorithms.
Let's look at an example. So post the data gathering, we have fed it into a table where each column represents a feature such as last quarter sales, market share, new users last month, etc. The stock price column shows the price of the stock of the company for different dates. And each table row represents observations across those features. For proper data analysis, we need to focus on all observations for a particular column or feature and total it. Here, we can see the total of the sales figure for all months as well as quarter-wise. Once we have inserted the data in the table, we need to focus on the aggregate of table data. It means either counting the total observations in a table and or combining multiple table data to answer a particular question. This brings us to the next step of machine learning workflow, which is the data analysis. This is an example of performing aggregate, distribute, and compute, and measure operations on data in tables. The aggregates are the date, day of the week, and Dow Jones columns. The distributes are each feature and their observations, which are distributed across the table. They need to be combined. The compute and measure is the Dow Jones number that need to be added in this case, and they need to be measured against the company's numbers for sales, market share, etc. in previous days and months. After performing all the previous steps, we can estimate a company's market share column values. Step 4. After the data computation and analysis, we need to determine if the data is acceptable for further investigation. For any algorithm to read data from a column appropriately, the data must be in a consistent format. Let's understand this step with the help of an example. In this table, closely observe the birth year column. We can see that the entries in the birth year column are written in different formats. Some are written within quotes, while some have hyphens before and after the dates. For any algorithm to read the data in each column appropriately, it needs to be formatted with consistency. So we will need some